Alrighty, Algebra 1, Day 5, converting linear equations from standard form to slope-intercept form. So, let's go ahead and talk a little bit about what in the world this is, okay? So, first of all, remember, as I told you, there's usually a standard form for everything. It's usually alphabetical order, biggest exponent to smallest, right? So, standard form well, actually, let me start in a different place. So, lines, right? They usually look like this on a graph. And they can face a couple of different directions. Doesn't necessarily always have to be exactly like these, but you get the general idea. These guys have a couple of different equations. Those equations give us a relationship in between x and y. They tell us, well, when x does this, y does that. And when x does this, y does this. It tells us the relationship, okay? All right, so now that we understand that, let's talk about the different equations that we have. So there's three that I know of. There's standard, there is the one that people are mostly familiar with called Slope-Intercept, y equals mx plus c, and of course there's point slope. And this one has a very, very, very specific purpose, okay? Now, which one of these would we use? So here's the thing. The one that is so totally easiest to graph with is this guy, slope-intercept form, okay? That's the one that's easiest to use to graph. Why? Because we can plug it in. It tells us a lot of information about where to start the line, how to move, all these other things, okay? Standard form's used for something else. Point slope form, though, is usually whenever I'm given a point and a slope, and I'll plug them in, and then I rearrange to get slope-intercept. So let's talk about a little bit of the interplay between these. So you can actually switch back and forth between all of these. All you have to do is maybe move stuff, divide, multiply, add, subtract, okay? And you can end up getting in between all three of these forms. So let's talk about what their features are, okay? So specifically for this one, standard form, my A and B are whole numbers, mostly pertaining to A. A is not negative, and X and Y on the same side, with C on other side. So if there's a number by itself, even if it is a 0, it's always got to be on that side. Now, slope-intercept form. Let's talk about that one. So this y here, it's always one y, always positive, and always alone. Always. Okay? This guy is called my slope, and this is called my y-intercept. Notice slope-intercept. That's where it comes from. It's got an M and a B. Slope-intercept. Now, this one over here, we're not going to go into too many details, but essentially, the ones that I'm putting an arrow under are the only ones that you plug in, okay? And then you can rearrange to get one of the other two. So let's talk about how going from standard to slope-intercept is super easy. Okay, so let me write that down to brown. So heading in this direction is super easy. Why? This is just exciting move, great divide. So that's wonderful. And the good news is that today we are only going to go in that direction. So we don't have to worry about going backwards. Going backwards, that's a whole nother level of something, okay? So let's go ahead and get started on today's notes. All right, so converting linear equations from standard form, ax plus by equals c, to slope-intercept form, y equals mx plus b. So to write linear equations in slope-intercept form, we use the formula y equals mx plus b. To write them in standard form, we use ax plus by equals c. So when we convert, right, I guess that's what you would call it, from standard to slope-intercept, we are solving for a specific variable. In this case, y. So, just a little bit of vocabulary, because this will come up again. When I say solving for, that's also the same thing as saying get it by itself. That means move everybody else away from it, get rid of all the numbers, negatives, other variables, move them all to the other side. So, the steps, I'm not going to worry about that because that's a little bit more complicated than what I like to do. My steps for this are always exciting move, great divide. Just as a refresher, exciting move, who's not touching x, and great divide, who is touching x. Okay? So, there are some people that like to memorize formulas for this. Okay? I'm not one of those people because I hate memorizing extra formulas. I prefer to just do it because sometimes I'll totally forget it and, mess it up or do it backwards or something. But this may be something that's helpful for checking your work. Okay? So let's say, for example, that I started off with this guy, right? Standard form. In your mind, imagine here some numbers, random numbers. Doesn't matter. So I need to get it to look like this. Y equals mx plus b. Okay. So if I notice, the feature over here is that y is by itself. It's completely alone. It's one of them and it's positive. Okay. So that means I need to get this guy by himself. And I need to get rid of that b, that x, that a. So we do the same exact process. So up here for this one, sorry, it should be y. So used to saying x. So exact same process. Okay. So I can move great divide. Who is not touching the variable that I'm looking for? This guy. So I'm going to subtract him because he's positive. Okay, and I end up with by equals negative ax plus c. Okay, good. So now I'm going to go ahead and do my great divide. Divide by b. Everybody that I see gets divided by b. Y is equal to negative a over bx plus c over b. Now, the interesting thing is that matches my y up here, right? Here's my x. Here is my slope. And my small b, my y-intercept. Totally different than big B down here. Okay? So, That means if I was a really good scientist and mathematician, I would notice that slope is equal to negative a over b, y-intercept is equal to c over b. So some people store these equations in their little brain and they use them over and over instead of going through all of this. I'm going to tell you it is probably not the best idea, but this is a good way if you're running out of time on a test or if you're checking your work, okay? So let's go ahead and take a look at example number 1. So first, let me get a good color. So we need to go to slope-intercept form, y equals mx plus b. That means that I need to get this y by itself. So I'm going to do my exciting move. Great divide. Noticing I can write these interchangeably, okay? Negative 3x divided by 4 is the same thing as negative 3/4 x. Is also the same thing as negative 3 all divided by 4 multiplied by x. You will see all three of them. Math people like to make stuff complicated, okay? So just to verify my answer, I'm going to go ahead and say slope is negative a over b. Y-intercept is positive c over b, okay? So I'm going to go ahead and color coordinate. Here's my A. Here's my B. And here is my C. Let's plug those in. First, I start by putting the negative A over B. C, 8 over B. Notice exactly the same. I only did that to verify my work, okay? Example number 2. Alrighty. So I need to make it look like y equals mx plus c. And I write this every time just to remind myself where I'm headed to, okay? So I'm going to go ahead. I need to get my y's by themselves. I'm going to do my exciting move. Notice how that negative stays with my y. And I write the x in the front because I want to make it look just like this guy. Great divide. And I end up with slope-intercept form. You could go back and check it, but you don't need to. It's correct. Alrighty. So I'll keep it short today. I hope this was super informative. Go ahead and get started on your assignment, starting with these examples here, and then you can continue to move on to the main. Good job, and let me know if you need any assistance.